Hello everyone. So in today's video, we are going to do this question. The question is from Putnam year 2023 and the question number is B4. This question was sent to me by one of my students and then I tried to solve it, and also I found the official solution. But in this video, I'm going to present the solution what I thought and how I worked on it. So first of all, what the question is saying, let's understand. So the question says that for a non-negative integer n, a strictly increasing sequence of real numbers t0, t1, tn up to tn is given, that is sequence of this subscripted real numbers, and ft be a corresponding real valued function defined for t greater than equal to t0. And this function has four different properties they have given. The first property tells that ft is continuous for any t greater than t0 and is twice differentiable for any t greater than t0 except these subscripted real numbers like t1 to tn. So these are real numbers, not the integers, first understand. The second property is the ft0 value is given half, and the third property is when we find the limit of the derivative of the function at tk plus from the right hand side, we are getting this 0, and it is only when we are taking k goes from 0 to n. Now the fourth property is crucial, and from where only we have to start our solution. So the fourth property tells that the k lies between 0 and minus 1. So function second derivative, this f double dash t, has two definitions. This is k plus 1 when t lies from tk to tk plus 1, and the second derivative again, it will be n plus 1 when t is greater than tn. So what they're asking, that considering all choices of n, that's also important, considering all choices of n, and also that the t0 till tn such that tk is greater than tk minus 1 plus 1. So that is also important one, that you can notice that the tk minus 1 is greater than 1, and it is actually when k lies from 1 to n. What is the least possible value of t for which ft naught plus t is 2023? So the question is very lengthy, and also the solution will be, and it's very difficult question, so I am trying to present it in a simpler way as far as I can. So before jumping to the solution, let's solve it. Means you can try, give your try to it, and if you solve it correctly, your answer should be 29. So let's start solving, and this is very lengthy and it's also very difficult to understand perhaps, but let me try to explain. So the thing is that here I have to find out ft naught plus t. So anyhow I have to find the function itself, or if we are not finding the function, we have to reach till the function by using these two definitions of the function given at the second derivative. So from there we start, and you notice that here they have given tk to tk plus 1. We understand what is the meaning of t naught plus t. First let us reach till f. So for that I'm integrating, and I'm using this first part, means let's call it this first definition and the second definition. This is the definition given for the this thing, non-differentiable points at which the function is not differentiable, because these are the points at which the function is not differentiable. So for 1, what I'm going to do is I'm integrating this second derivative from tk to some number t which is lesser than tk plus 1, and on the right hand side I have second derivative, and on the left hand side that thing, and the right hand side I have again tk to t, and the constant is k plus 1 and dt. So you notice when you integrate it, I'm writing quickly, so I hope you understand. F dash t minus f dash tk, and there we get k plus 1 and then t minus tk. You can also understand that the f dash tk is some constant value, so I can bring this constant value that side and write that f dash t is equal to k plus 1 t minus tk and plus some constant c, where this c is f dash tk, because tk was a fixed real number, and on that you are finding the derivative of the function, so that must be constant. Now the third property here that is given there, try to observe, when t approaches tk plus f dash t is 0. So when this is not the approaching value, this is a fixed value. But when we set this thing there, that when you apply the limit t approaches tk plus f dash t, and here also apply the same limit on the right hand side, because of this gap t minus tk, that gap will be 0. So I can write 0 plus c, and this value is given 0 in the question, therefore c will become 0. So c becomes 0 means f dash tk is actually 0. So it's a constant, and that constant is 0. So this will lead us to write the f dash t in its updated version without c, that f dash t is k plus 1 and times t minus tk. Now we have the first derivative known. We can integrate it, and after integration we got the function, and after that we think. But the integration we have to do in wise manner, or let's integrate it and then I will explain. So suppose I'm integrating tk to t, again same thing, and that is f dash t dt, and here I get k plus 1, and there if you integrate it you get t minus tk the whole square by 2, and it is again from tk to t. Now we are actually getting till t, but do you think that this is tk to t is going to happen? Because at t1, t2, t3, t4, tn, all are the functions are not differentiable, correct? If not differentiable, it means we have to break it down between the interval actually, because at the tk and tk plus 1 the function is not differentiable. So this t must lie below tk plus 1. So in this way what I can do, I can substitute this t is equal to tk, not tk, tk plus 1. Then what we get it here is f dash tk plus 1 minus f dash tk, and that is equal to that side also. If I substitute tk plus 1 there, what I get is, when you substitute tk, that will become 0. So this side I get k plus 1 by 2, and this tk plus 1 minus tk the whole square. Now the idea is that when I want to find the accumulated value of this, this is not the function first derivative, by the way, this is the function, that's my mistake, so please rectify it. Now ftk plus 1 minus ftk. So the idea is that we are going to find out the accumulated version. Suppose I'm putting k is equal to, because you notice that k value, the subscript is here 0 to n. It means suppose you want to write the k is equal to 0. So at k is equal to 0, that will give you f1 minus f0, correct? It means this side of what I'm getting, let me just show you something. So f1 minus f0 means ft1 minus ft0, I mean to say, not f1 directly. So ft1 minus ft0, and this side also you get, and you add them up, what you get? If you add them up, you will get this thing, the first term and the last term, means the t, because k is going from 0 to n minus 1 if I take here, because I need here tk to tk plus 1. So if I'm taking 0 to n minus 1, that will give you 0 to n, which the idea is that, let me tell what I mean to say, that if I'm accumulating this, k goes from 0 to n minus 1 this side, and I have f of tk plus 1 minus f of tk, and there again I'm applying this summation, that is summation k goes from 0 to n minus 1, and let's call this tk plus 1 minus tk as delta k. I don't want delta tk, I don't want to mess up always, so that is going to be delta tk square, correct? Okay, so the idea is that if you want to add this side, that will be correctly added, because if you substitute there k is equal to n minus 1, you get f tn minus f t naught, and on this side I will not have any chance to get them added because I don't know the exact value of t1 t2. So I will write like this only, k plus 1 by 2, and that is delta tk, that is the difference between the two consecutive things, and square. So this is the one version we got when the function was defined in those points, the function is not differentiable in such a way. But what will happen for this part? You can notice this is smooth, because when this is n plus 1, when t is greater than tn, so when you reach the last term there, means here it is already there, and after that smoothness is happening, means there is no such point after this where the function is not differentiable. So for that also, if we carry like this, we get there for 2. You notice the idea is very simple, because is analogous here, that is going to be n plus 1, here k plus 1. So if you do the similar process of integration twice, and if you go tn to t actually, because till there we have got the tn, now we have to go from tn to t. So when you're going from tn to t, the similar kind of integration or the summation you get, I can write ft minus ftn, and this side I have n plus 1 by 2 delta n square, because we are going from tn to, because here delta n means that t minus tn, it means we are going to t from tn, the gap is this one. And now the idea is that if you want to find the ft naught plus t, what is the meaning, is this one. The problem is that we are starting at t naught, and they're asking the least possible value of t, means in the form of time. If you want to understand, they're asking what is the least possible time starting from t naught the function will attain the 2023, because this is the initial point, and from initial point what the time length you get to get the 2023 minimum, at the minimum time length. So maybe the t is this time what you are looking for, this is t plus t naught I can put, but I have to first accumulate all the time. So what is the meaning of this capital T they're asking? The t is nothing but those all time intervals, or the intervals what we got on the real number, which was actually in the discrete portion when the function was not differentiable by this definition on those sequences, on the points of sequences here t naught to tn, and also by accumulating those time or those gaps which are achieved from this definition. So what I mean to say that the T is nothing but all those gaps. K goes from, so K goes from 0 to n minus 1, all this delta K and delta, not delta K, delta Tk, and plus this delta n. This is the meaning of the T. And this we have to minimize. So this have to minimize this thing. So for whatever I have understood, this is the thing I can do. Now see, the delta Tk, there was information there in the question that this value is there, Tk greater than Tk minus 1. So Tk greater than Tk minus 1 plus 1 tells that the Tk minus Tk minus 1 should be greater than 1. So this is nothing but delta of Tk minus 1 greater than 1. Or if you start from k is equal to 0, you can write delta k. It means delta k is greater than 1, by the way. It means between any two consecutive such T1 and T2, Tk and Tk plus 1, the minimum value is 1 there. It means if I need the capital T minimum, I can substitute this value as 1, all this value. So what we are getting here is k is equal to 0 to n minus 1. This is 1 and plus delta n. It means now I got T is equal to, that is going to be n, because 0 to n minus 1 plus delta n. It means that everything depends on delta n. If I get the delta n minimum, I can get the value T minimum, and that is the question it's demanding. So how do we get the T minimum? We have to see from these two information we have so far achieved. So this thing and here this thing. So now you can see that this is also some time intervals, the gaps, and these are also some time intervals after this Tn. I can accumulate all of this so that I can see that what will happen. If I add them up, what we get, the Ft and Ftn will cancel, and we get this Ft is equal to, okay, let me, so Ft minus Ft naught get, so I wrote here F equal to, so I can send this Ft naught right hand side, and plus this side I get summation k goes from 0 to n minus 1 and k plus 1 by 2. But notice already for the minimum of T, the delta k square I have achieved, that each delta k is 1 minimum. So I can put the same value there. So that will give you summation k plus 1 by 2 for that, and on this n plus 1 by 2 delta n square I get. So Ft naught you got, and now I'm going to put this value. What value? F of capital T plus T naught. Since actually there is one size kind of a loophole, that here I should put first T plus T naught, and then I should put delta K is equal to 1. So if you are very sentimental to see that, let me just write this thing this way. There's a delta K square and plus n plus 1 by 2 delta n square. Now I am substituting T plus T naughts. It means I am trying to achieve that small t. So I'm getting f of T naught plus summation, and here I'm writing k 0, n minus 1 and k plus 1 by 2, and that is going to be 1 each of them, and that is going to be n plus 1 by 2 delta n square. Now what is the plan? The plan is that this value is given there, that is 2023. This Ft naught is also given, that is half, and this is the summation starting from 0 to n minus 1. So this can be half here, and this is going to be n into n plus 1 by 2, and plus this is going to be again n plus 1 by 2 and delta n square. So the idea is that if I can find out the delta n in terms of n from their equation, I will substitute there in this equation and we get the smallest value of t. So our aim is to find out the minimum value of delta n from this equation, and that is the main thing I have. So that is going to be what? I will just multiply by 2, so it will become 46 minus what we get here, 1, and that is going to be n into n plus 1 by 2 plus n plus 1, because I have already divided by this, and this is going to be 45, and I'm dividing by n plus 1 also, so n plus 1, and this side what I'm getting is 1 not n by 2 and plus delta n square. Okay, so I got the delta n squared is equal to 45 by n plus 1 and minus n by 2. Now notice the delta n square cannot be negative quantity, so I can say that from here that the 45 by n plus 1 minus n by 2 should be greater than equal to 0, and that will give you what? N into n plus 1 n into n plus, let me write it, I'm very bad at calculation, let me just write 45 by n plus 1 is greater than equal to n by 2, so that is going to be 90 is greater than n into n plus 1. So let's try to see what is happening. Let's substitute there n is equal to 90. If I substitute 90, so 90 into 91 is going to be 81. So I think the n value should be 81. So n has the maximum value 89, not 81, 89, but we have to find the n minimum value, means sorry, not the minimum value, we have to find the minimum value of delta n. So we got that n can be this thing. So one way is that, let's suppose I'm trying to find out, no, the problem is that is not the minimum value of delta n. We have to find, because this is also depending on n, that's the problem. This is also dependent on n, so I have to take this thing delta n there and then find the minimum value of t. Okay, that will not work but the way I was thinking. So I'm just making a function tn, that is a n plus, and now delta n is this thing, the square root of it, that is 45 by n plus 1 minus n by 2. So previously I thought that it will work, but not, because this was also the value n there involved. So delta n minimum will not work, because at the same time n will change. So that logic was not correct. So I am just rectifying it. The idea is that I found the delta n in terms of n by using the information given, and that delta n I'm going to substitute there in the expression for t, and t will be a function of n, and now for what n the t will be the minimum, I have to find it out from here, and that is very crucial. So I got here n less than 89, so that's the maximum value we got. So how do we make this? So one way is that we can make it continuous type of thing, and we just write this is a function of x, like a tx, and find the derivative, and from that derivative we get the maxima minima kind of situation, and from there we can get it. So that is not like a very easy one, because finding the derivative and again setting the derivative equal to 0, and from there we find out the minimum maxima, that is also a very difficult task. But the idea is that, can we think, because n is a natural number, n has integers, actually positive integers, so we can try substituting and check it. So if you substitute, let's say I'm substituting n is equal to t is equal to 1, because in the question itself is saying, there's a very wonderful line is given there, you read it here, the considering all choices of n. So all choices of n means we are considering all choices, very difficult to consider all choices, and also the n are distinct. We have to be very careful because we are making this continuous and it's very difficult. So let's try and we'll see. So t is equal to 1, what we get it here, that is going to be 4045. I don't know Putnam exam has a calculator allowed or not. I hope it is allowed there. And from there we get 1 plus something. So in this way I found that the value at 9, the value at 8, and the value at 10, and so on. So in this way I found with calculator and all. So T8 is greater than T9 and T10 is also greater than T9, and further the values are greater than every value of T9. So when we substitute n is equal to 9, we get the minimum value. And what is the value of T9 is very interesting, that if we substitute 9 there, we get 9 plus, and here 4045 by 10 and minus 9 by 2, so that I can write as 9 by 2, that was 15 by, not 15, 45 by 10, because 9 by 2 I can write. And so we get 9 plus, it is 40, 45 minus 40, this is also 10 by the way, 400, not 400, 4000 by 10, and 4000 by 10 is 400, and the square root of 400 is 20, so the answer is 29. So the last part was a little bit cumbersome to go with all the integers, because when you differentiate this thing, it was very complicated to get this set the t dash x 0 and get the value x equals to 9. I have tried it, but from there any student can think, but understanding the question was difficult a little bit, and this is beyond JEE Advanced and all. But since one of my student has sent to me, and it's my duty to clear the doubt. See you in the next video with some other interesting question. Stay math active.